All right, time to do the second half of lesson 1.3. One thing I should have mentioned, in the first video is some ways that I remember complementary and supplementary. So sometimes making connections either with a figure or a picture, but also just some sort of mnemonic helps my brain remember some things. For this one, for example, complementary starts with C, and so does corner. And the corner of a room is always 90 degrees. So I think complementary corner, right? Think about the corner of a room. We've got some 90-degree angles. Complementary corner, 90 degrees. And then for supplementary, I think supplementary straight, and straight is 180 degrees. So supplementary straight 180 degrees. Let's take a look at two other types of angle pairs, and then we'll do some sketching based on those lines that I had told you about. And then we're going to do a little bit of logical reasoning. So vertical angles. Vertical angles, they are formed by two intersecting lines. And then I'll get to the next part. So here's our first line, and then here is our second line. And as you can see, there are actually four angles formed by these two lines. One here, two here, three here, and four here. So the vertical angles formed by two intersecting lines, where there are four of them. The angles that are considered vertical share a common vertex, but no common sides. So remember, adjacent angles share a vertex and a side, but not interior points. Vertical angles share a vertex, but not a side. So if we look at this picture, angles 1 and 2 are showing us what vertical angles look like. So here's angle 1, and here is angle 2. And what I would like you to think about is folding or reflecting something in water. So if this was water and I had angle 1 here, and I flipped it over, here would be angle 2 under my water. And so I like to think of vertical angles form reflected V's because vertical starts with V. And we also have a second pair of vertical angles created here. Can you see where they are? Oh, I guess I should have left that up on the screen. Sorry, everybody. Our second pair of vertical angles are right here. This angle here and this angle here. Again, you can see the V shape and they're kind of reflected over each other. We're going to learn some important things about vertical angles in chapter 2. And our last definition is linear pair. So a linear pair is a special type of supplementary angle, which we're again going to discover in chapter 2, but they are a special also type of adjacent angles. So they are a pair of angles, and we could even add adjacent if we want to. So they share a vertex and a side. So that's technically the adjacent part. But this is the part that forms the linear pair as opposed to just being adjacent. Their non-common sides form a line. So here's angle 1, here's angle 2. We have the vertex that they share and the common side, making them adjacent, and then the non-common side, so this side for angle 2 and this side for angle 1, if we put it together, we get a line. So linear pair, think of it that way, makes a line. So pair means two, linear, they form a line. So hopefully I've given you some ways to memorize some of these things just because there is a lot of vocabulary and we want to kind of find some connections. Let's go back to our notes for a second and take a peek at some sketching that has to do with our types of lines, parallel, perpendicular. We're not going to really sketch any skew lines because we don't do a ton of three-dimensional geometry just in general here, but we will do some three-dimensional geometry later on in the course. We are going to sketch and label the figures below. Remember, sketching is pretty imprecise. You do not need to have a straight edge with you, and it doesn't have to be perfect, though it should look very close. But labeling is really what I'm trying to get us at today. So the first thing we're going to sketch and label is L1 is parallel to L2. Now, this is something I haven't talked about yet. We know that there's a couple different ways to name a line, if you recall that from lesson 1-1. So if you want to go back and look at that vocabulary, that could be helpful. We can name a line by 2 points, but if we have a lot of lines in a figure and things are kind of messy, or we want to keep it a little bit cleaner, what we're going to do is we're going to name lines by lowercase cursive letters. And so in this case, I'm using L for all of my lines, but then I'm using this little subscript notation. And you might have seen this in Algebra 1 subscripts using like x1, comma x2, or x1, y1 when you're talking about slope or something like that. So we have used subscripts before. We also like to use M's, N's, and P's for lines. So here I have L1, and L1 is parallel to L2. So then I'm going to draw L2. So parallel lines lie in the same plane and never intersect, and they're always the same distance apart. So here's my L2. When I notate parallel lines, again, if you go back and look at the vocabulary sheet up here, parallel lines are notated by these arrows. So tick marks equals congruence, and lines, little arrow marks are for lines. So you always, again, put the same number of little arrows in the lines that are parallel. So I'm just going to give these one little set of V's here, little arrows, little V's. All right, and then L2 is perpendicular to L3. So perpendicular, again, means they intersect in a 90-degree angle. So when I draw L3, I'm going to try my best to make it 90 degrees. Here is my L3, and it's only perpendicular to L2. So I'm just going to put my corner box right here. Now, I'm hoping you can infer that it will also be parallel to L1, although we technically don't know that yet. We're going to learn about a couple things in our next chapter that are going to help us with that. Okay, for the second one, again, just practicing lines, rays, perpendicular, just kind of really integrating all of the information that we have. So we're going to start with segment PQ. Because it's a segment, it has 2 endpoints, and I label the endpoints as such. And it is perpendicular to ray PR. Now, this is going to give me an opportunity to talk about what happens when I use the same point in a picture. Well, if I use the same point in the same figure, they have to be the same point. And so when I draw ray PR, I'm not going to draw a separate ray over here and label it PR, because then I would have 2 point P's in my picture, which I do not want. So I'm going to go back to my original point P. Because it's perpendicular, I'm going to draw it 90 degrees. Again, I have a ray here, so I should have an arrow at the end. I know my endpoint is P, so I don't really want to go beyond that. I'm going to draw my corner box because it's 90 degrees, and I'm going to have a point R on there. Again, I'm using different colors just to kind of highlight some things, but you guys are just sketching in pencil. Okay, question number 3. If the measure of angle P is 13 degrees and the measure of angle Q is 77 degrees, okay, and Q and R are complementary, what can you conclude about angle P and angle R? Okay, and explain our reasoning. And we're going to be working on explaining a lot in this course as well. Because in mathematics, it's not just about what you know, but it's about communicating what you know. And especially in geometry, communication is really one of the highlights and focal points. So let's just unpack this a little bit. So I have angle P and angle Q, and I know that angle Q and R are complementary. So if angle Q and R are complementary, what do we remember from our definition? It means their measures sum to 90 degrees. And so that I know the measure of angle Q plus the measure of angle R is 90 degrees. So I'm just going to write some algebra here. I'm just going to use my algebra skills. I know that the measure of angle Q is 77 degrees. So I'm going to go ahead and substitute that in. And now if I subtract 77 from both sides, notice that the measure of angle R is 13 degrees, which is also the measure of angle P. So what can you conclude about angle P and angle R? Angle P is congruent to angle R. Now, explaining this, again, you could do what I did here, and you could say, because angle Q and angle R are complementary, and the measure of angle Q is 77, we can solve for angle R and get angle R is 13 degrees. Therefore, angle R is congruent to angle angle P, because they have the same measure. Or you could go back to this and say, the measure of angle P is 13 degrees, plus the measure of angle Q is 77, and they are complementary because their sum is 90 degrees. And since angle Q is complementary to angle R, and they are also complementary, that means angle P and angle R must also be congruent, because we have the angle Q in both of the relationships. We have the same angle. It doesn't really matter the way you explain it, as long as you're including all those details that I talked about. So let's put some things together here. We actually have not talked about triangles, so I'm going to actually strike out number 4. All right, let's talk about number 5. Through a point not on a line. And again, what I like about going through this is just kind of like sketching and drawing and thinking about a counterexample. So through a point not on a line. Okay. So we have a line, we have a point not on the line. And through this point, one and only one line can be constructed parallel to the given line. So this is the given line. Okay, so again, can I construct one? I can. I can go through it right there. The question is, can I construct a second? So can I put a second line through that point that is also going to be parallel, but not, of course, the same line I've already drawn? The answer? No, I can't, right? And so this is true. I wanted to model for you how I would look at this and decode this. Okay. In number 6, if CA equals AT, therefore we know a couple things here. We know that CA is congruent to AT. They have a measure. And we know that we have point A in both of these. Then A is the midpoint of CT. Well, let's think about this. I could have this situation, right, where I have C, I have T at the end, A in the middle, where CA is congruent to CT. And in that case, yes, A is a midpoint. But can we think of something else that fits this? The answer is we can. And that's because what we didn't get told here is that CA and T were collinear. We didn't get told that they were on the same line. And so what I could have is this sort of scenario where C and A make a segment that is connected to A and T, but C, A, and T are not all part of the same line, or C and T are not part of the same line with A, and therefore it's not always true. So this is false, and this is our counterexample. Okay, and then our last one. If the measure of angle D is 40 degrees and the measure of angle C is 140, then angles C and D are a linear pair. Well, we know that they're supplementary, right? Because we know when we add them together, we get 180 degrees. Okay. However, are they a linear pair? No, because if two angles are a linear pair, then they have to be adjacent. How do we know these angles aren't adjacent? Because they don't share a vertex. Don't share a vertex. And we know they don't share a vertex because the vertex is what we use to name the angle, and this is angle D, and that is angle C, so they must be different angles. In this case, I said draw a counterexample, so we could draw a counterexample, but you could also give a counterexample through explanation, kind of like what I did here. So here we have angle D is 40, and angle C is 140, and they are not a linear pair. Great job doing section 1.3.